gas canister. Because if it would be on a rail for our sim scale with a gas canister, it does not know that the car is on the rail. Thus, I could not simulate the airflow against it. Because we have put it as if it's actually driving through the track, while the airflow would just be opposed.
For the dimensions, we maximize to be as low as possible, as the range is from 26 to 34 millimeters. We were trying to minimize it as maximum as possible. It got to approximately 28 after calculations. The weight was the minimum, as minimum stated, was 48 grams. We were aiming to at least 50 in order to reduce the drag because of the weight of the car.
But another team is entered the meeting, so
okay.
I think we can proceed with another one. Qazaqstan, thank you so much.
Thank you.
Also, our full manufacturing process is all in technical portfolio.
Yeah. Thank you.
Thank you so much. Goodbye.
Goodbye.
Ogma team, are you here?
Hello, can you hear me?
Yes, we can.
Yeah, so we're here.
Okay, can you share your screen?
Yes, just a second. Just like I'll. And we'll just in a second, we'll turn on the camera. Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.
Hello.
Hello.
We're at Mogma.
Oh.
So let's start.
Okay, you have 6 minutes for your presentation and 6 minutes for the Q&A.
Can you see our presentation?
Yes, we can.
So we can start?
Yes, you can start.
So, hello, we're Team Ogma. So let's start with our engineering components. How to move on? Okay, so let's start with the methodology. Firstly, we took our methodology from research paper about F1 in schools. It was iterative, and as you can see here, we used it during whole our CAD designing.
Many of us are engaged in aerospace engineering, so we were inspired by Formula One cars and also rocket modeling, as you can see here from our hump. Okay, to explain it, we added a variable CO2 thrust idea. Here you can see an improved equation on graph and acceleration against time. This model shows that the race can be divided into two important phases. At the beginning, car mass strongly affects acceleration. Later, aerodynamic drag becomes more important, and this explains why the final design should not only rely on low mass, but also on losing aerodynamic reduction too. So you can see here our drag coefficient was 0.91, and the second version key idea was to incline the air tube by 3 degrees to make great downforce. It gave better aerodynamic potential and more controlled downforce, but from cons, we spent too much extra vertical force. It reduced the velocity. Recently, from Alexander Artemyev, the only elements 24 hours Qazaqstan Racer, we got the feedback over our innovation for 3 degrees. He says that in our scale in steam racing, where we have 20 meters straight line track, the downforce is not as significant. That's why in later versions we changed it.
So we also consider the boundary layer behavior as air flow just moves along the car body. A thin, a thin slower layer forms near the surface due to viscosity. Its thickness can be estimated by boundary layer equation on the slide. If the body has sharp transitions, this layer can separate early, creating large turbulent wake and increasing drag. Therefore, our CAD design uses a smoother nose, curved side, and our CD was 0.88. We also took feedback from IFO silver medalists. And he designed our version 3. He helped the design.
The version 3 idea, key idea was to make broader side bearings to skip the air around the wheels and make a new front wing from Picasso's feedback. So it had better aerodynamic potential. As you can see here, the coefficient fell to 0.87, but it also the rear wake was still too aggressive.
Yeah, we also took another feedback from MIT student and also I4 silver and IAA gold medalist. So he said like, we should pay attention on the rear section and make it less sharp and just near CO2 cartridge because it can create a larger wake. We also implied aerodynamic drag because it depends on the pressure distribution around the car. As you can see on the CFD screenshots, a large low pressure wake behind the car increases pressure drag by pulling the car backward. To reduce this effect, we avoided an aggressive car wing and designed it as simple as possible.
So our final version coefficient of drag was 0.44. It fell drastically by 44%. And as you can see here, we made a totally new hump. It was shorter, inspired by rockets. Also, we made drop shaded, shaped on side's rear wing and new, sharper, shorter nose. And also, it was easier to manufacture. It ideally lifts the air, but from concept it takes more time to manufacture. As you can see here, we made 2 iterations.
So let's move on inspiration. Here you can see the evolution of our wings. We also inspired by Cars movie car, Dinoco, our rear wing. We also took the birds parts to make our nose sharper, and also didn't forget about the biomimicry connected with water drop for the stabilization of rear wing. So moving on CFD design, just make the analysis. You can see the small algorithm of it, how we made from the start to the run of simulation. We also use some parameters that you can see on the table, and we also need to find the surface on Fusion 360. Here you can see the CD comparison of last 2 cars. As you can see, it was a huge difference, like approximately 50% of difference reduction of coefficient of drag. So we use also the data from the research paper about the fun schools and took this formula too.
We also made FEA analysis for the last car. As you can see here, we applied force of 67 newtons, but it was too risky. As you can see here, our first front wing broke down because the mounting was bad, and we made the second iteration out of FEA.
Hello. We have 2 main priorities: staying within the regulations and keeping the car as light as possible. We slice our 3D printed parts in Bamboo Studio and generate the CNC tool paths for the body in Fusion 360 manufacturing. The same software we model in. So there are no file transfer errors. The body is milled from the official foam block and everything else is 3D printed. Our biggest experience came from the front wing. The first one cracked along a layer line because it was printed in the wrong orientation. We reoriented it so the layers run along the load, not across it, and it held. For the printed parts, we keep infill low and use a gyroid pattern, which is strong in every direction, and we prototype in PLA before printing the final parts in carbon fiber. More you can see in our portfolio.
Sorry, your time for presentation is up.
So we have time, right?
So you have 6 minutes for the Q&A session, not for presentation.
Can we have 1 minute more, please?
It depends on judges, and I think no. And 6 minutes for the questions and answers. Good luck with that one. Your time goes now.
So,
So, do you have any questions? Because we can demonstrate our car. Maybe if you're interested in manufacturing, because we couldn't cover it fully.
Yeah, we can show you our test results, kind of.
We made 3 iterations of our manufacturing. Here's the final one. So you can see out of FEA, we understood that we applied the force 143 times more than the car's weight. And as you can see, it is really strong. For example, here are the Tether guidelines. For the manual, it should be really strong.
It should withstand 300 grams at least.
Can you show your model?
Can you repeat, please?
Can you show your 3D model of your car?
Or, 1 second. Here you see the browser or the history. Just
What's the type of bearing you use? You say before you used bearings, and what's the type?
We want to use actually hybrid bearings. They have ceramic balls inside them and very low friction. And they are actually a little bit less heavier than basic steel bearings. But now we're using steel bearings because we didn't have time for these hybrid kind of bearings.
here also can see our pigeons cut. If you don't mind, we can tell you about it because we have a quite interesting engineering idea. About
Do
the
you have questions?
Just about the pit zone, shortly, it's made out of the recycled cardboard, and the approximate expenses for that is going to be around 180,000 tenge, including the tablets for simulations and showcases. So that's gonna make our audience more interested in our project and like develop the marketing strategies others too.
and it also works on hybrid.
Can you tell us more about your manufacturing plan?
Can you repeat, please?
Can you tell us more about your manufacturing plan? So, like, where are you gonna manufacture your car? Maybe you found some CNC machines in Almaty. I don't know. Maybe somewhere in Kazakhstan.
Okay, we thought that we can find a CNC machine in universities or just in the city. So for example, Sabaev University or Qazaqstan, because Qazaqstan definitely has a CNC machine. Then other parts except body will print it out of PACF.
Carbon.
Yeah, it's a carbon fiber filament for 3D printer. Everything else is wheels, wings, halo, and helmet. And body will be produced from foam block and using CNC machine and using Fusion 360 manufacturing program.
Also, we told about that we made 3 iterations of printing. This here, and for environmental impact, we used for the previous versions, for testing versions, we used PLA, but only the last version it is from PACF because it is not recyclable. So as you can see, it is really strong.
What's the type of manufacturing you use for make your final model? It's all what you make your 3D model. It's you say is a testing model. What's the type of manufacture you use for produce final model?
Fiber model.
Mm-hmm.
Final model. What type of?
What type of material?
PACF is a filament. We used it to make wings or wheels, wheel axles, halo, and that's all. And everything else we made out.
No, another CNC machining you don't use? Only 3D
No,
printing?
we use CNC milling for body, of course. From out of foam block, it's a regulation requirement.
What's the type? What's the material you use?
You mean foam block?
Foam block.
Foam block.
Okay.
Well, It is said that we should use foam block from Denford, but it's a polyuterene, кажется, without pores.
Mhm.
Sorry, your time for Q&A is up. That's it for the Q&A session, but I don't see another team entering the meeting, so it depends on judges maybe they have additional questions.
We can show you the wheel.
Oh,
I don't have additional question.
okay.
Maybe about CAD or
Can you show your CAD model?
okay. I can show you the bearing for the wheels. It looks like this. So here it is the bearing, and we just glue it up. It is really strong, as you can see, and it is really fast. You can see it from our engineering portfolio. We tested it, and the car is really fast. I mean, the wheels assembly.
Can you show underside?
So it is here. It is empty to reduce the weight. And here it is the place for the CO2. I mean, CO2 cartridge or yeah.
So I think another team is entering, and we need to proceed with that one, but they left again. Okay, I think that's it for the presentation.
1 second. Can you show me the pit stop of my pit inside?
Pit zones or
Yes, you opened before one of the window is of my game.
yeah.
You opened before.
It is we have an innovative idea. You can read about it more in our engineering portfolio, and also about challenges from manufacturing, because as we had 3 iterations, it were a lot of challenges. And regarding to pit zone, for example, this is the equipment that our sponsor F1 Kazakhstan or F1 Kazakhstan gives us if we will pass to the international stage. And also we have it is the simulation, and also we have the second pit zone, but it is for it is for showcasing like ecological impact because it's made out of recycled cardboard, and also it has our own electric generator.
Yeah, which we took from our self-made e-bike. It's an BLDC 6394 motor, which you can
Okay,
use.
I'm so sorry for interrupting, but another team entered the meeting, so we need to proceed with them. Thank you so much for the Ogma Racing for that presentation.
Thank you too.
Thank you so much. Hope you can get more information in our engineering portfolio.
Thank you. See you.
See you.
Okay. Integrum team, are you here?
Hello, dear judges. Yes, we're here.
Okay, great.
We're gonna start broadcasting our presentation. Please, 1 minute.
Okay.
Is it visible?
Yes, it is. So now you have 6 minutes to present.
No, please, please. 1 minute, please. One more, like. Yes, we need to set up the camera. Are we visible?
Yes, you are visible.
Okay. 1, 2, 3. Hello, dear judges. We're Team Integrum. We're from 5 different schools, but shared with one obsession: engineering and speed. I'm team captain, and I'm Arman.
My name is Anger. I'm enterprise manager.
My name is Ansar, and I'm cadre of the team. My name is Oscar, and I'm a designer of the team.
My name is Camila, and I'm the engineer of the team.
So let's talk about our strategy. We identified 3 key performance indicators of our car: its car mass, aerodynamic drag, and wheel friction. Our car went through 3 development versions. First was YTA version, 74 grams, created mainly for CAD learning and initial testing. Then comes the ELSA version, 54 grams with a drag coefficient of 0.62. Better shape, better aerodynamics, but still not enough. And finally, our Stella version, only 50 grams with a drag coefficient of 0.61. Lighter and compact bearings, fully redesigned car, official sub racing material according to the manual, a better car in general. That's how our car achieves maximum efficiency and performance.
To analyze our car, we used 2 CFD tools, Autodesk CFD and SimScale. Running both helped us to compare results and improve accuracy. Our car travels at 22 meters per second. The nose cone smoothly squeezes the air, while the teardrop body keeps airflow attached to reduce drag. The flat floor lowers pressure underneath the car, creating ground effect and increasing grip. Vortex generators help us to keep airflow stable, and the diffuser at the rear strengthens this effect. Using the drag force formula, we calculated a drag coefficient of 0.61.
We created 3 versions before reaching our current wheel model. We decided to take a risk in favor of reducing the weight by 26.36%, while the strength increased by 11.5% due to the addition of 10 spokes and reinforcing grips to the latest version. After conducting research, we decided to use SMR70 bearings, which are twice as light and more compact. We have a lot of innovation in the car. Here are the key features. For some of them were inspired by the top teams from the previous year. Left side design changes. Rear wing, we made it thinner and longer. This helped air stay attached to the surface instead of the flying off. Back part, we added small triangular fins at the bottom colored vortex generators. They stop air from spreading sideways and keep it controlled.
And now let's talk about the manufacturing part, one of the most important parts. First of all, we're going to use the official STEM Racing block foam for our body with a density of 0.28 grams. Next, the wheels are going to be printed out of the Ketron HPV peak material because it's really stable and it doesn't have any fatigue from the long runs. And next, our halo is going to be printed out of the ABS material with a 20% of an infill. And what about our manufacturing steps? First of all, is preparation. After preparation on a wooden bed and double tape stick, we're going to have 4 main strategies and methods we're going to use. First of all, is 3D adaptive clearing on a very high speed with a 4.0 millimeters flat end mill. Next, we're going to change our mill to a 3.0 millimeters nose mill with a 0.15 millimeter step over. And at this time, we're going to use scallop strategy. And for the CO2 chamber, we are going to use the spiral path. So just like that, it's going to go through every curve in our car. And let's talk about the sustainability in our manufacturing part. We are choosing ABS instead of the PLA for our final car, but our prototype was made out of the PLA, as you can see, because it's more eco-friendly. However, ABS is more stable and it's not vulnerable at all compared to PLA, so we do not have to print it out a million times after every single run. And also, as my teammates already mentioned, we have lowered the mass from 70.4 grams to 50 grams. For 20 grams, we have lowered our mass. And that's why it means less manufacturing and less trash left from the manufacturing. And that's it. Thank you for your attention. And if you have any questions, you may feel free to share. And we're going to see you in 1 hour.
Can I add one detail? So we 3D printed our wheels. You can see it here. And we can prove it's very strong, like it doesn't break at all. Okay. Questions?
Can you show what removal of that?
Sorry, can you repeat? Can you repeat?
3D model of your car. Can you open it?
CAD model?
Yeah.
Could you give the share to the other computer? What? Integrum team number 2.
Yeah, turn on the mic on this computer and turn on this one.
Is it available to see? Can you see something?
Yeah, we can see.
Okay. Yeah, here's our model. So, okay, you can see like from our... не видно? What's up? Don't you see the car? What?
No, we see.
You see it? Okay. Comparing with the previous version, we have like changed nose cone, changed teardrop body, changed to rear wing. So the air could stay on the car, not separate because of Coanda effect. And we played with the vortex generators, adding it more. So you can see like here. Vortex generators is like this thing. Let me scale it up. What this thing? Compared to the previous version. Also here you can see tether lines according to the manual. Yeah, tether lines.
Do you have CFD analysis?
CFD, yeah, we can show it. So as we said, we used 2 programs. So here's Autodesk CFD. Okay, it lagged. Here's Autodesk CFD, as you can see right here, and we have also in a sim scale. Okay, here in the sim scale we have our analysis. But we use 2 programs in general.
Show CFD analysis by Autodesk.
Sorry, can you repeat? Open CFD in Autodesk?
Yes.
Okay, it's here. Askar, you know the controls better than Autodesk CFD. Here you can
Which
see.
feet do you put here?
1 minute.
What feet do you put inside it?
Can you repeat what?
Feet.
Sorry, your quality of the voice is very bad.
How much meter per second?
Meter, 22 meters per second. It's air velocity going straight to the car because car moves 22 meters per second in general. So air is like if the car stays in a different system, air goes to the car 22 meters per second.
Okay. Do you have any kind of processes like a G code or maybe simulation of?
What? Stress test? You mean stress test? FA test? FA?
Manufacturing processes.
Manufacturing? What?
Yeah.
Yes, how you will factor it and a simulation of factoring.
Our prototype? Our prototypes. We printed our Elsa car in 3D printer, PLA Plus.
It's like that prototype is 20% in field.
Questions about simulation of manufacturing.
Simulation of manufacturing.
Yeah.
We simulated our wheel with.
No. Questions about you simulate how you produce your manufacturing, maybe CNC machining, maybe 3D printing in Fusion or another CAD program have simulation of manufacturing.
Okay, so if we are talking about 3D printing, we have Bamboo Studio. We can send you like the file and show the simulation of its 3D printing.
G-code.
So we also did the models, so it will be minimum amount of supports because of supports the quality of model it goes down. So yeah, we simulated it and reduced the amount of supports on the model. Okay, he will send it to you.
Yes.
Because we don't have Bamboo Studio on that computer, it's on his computer.
At my back.
Any questions?
I don't have questions. Thank you. Maybe another. Others?
Yes, thank you.
Thank you.
See you later.
See
After
you
one
later.
hour.
In 1 hour.
Okay, great. Now we have Akku team. Akku team, are you here? Akku team. Akku team, are you here?
Yeah, can you wait for some time, please?
Okay.
Or other persons or people are connecting.
Akku team, are you ready?
No.
Please be a little bit faster.
Yeah, sorry for that. I think my teammates are having internet connection problems.
Maybe you will start sharing your presentation now.
Yeah.
While we're waiting.
Actually, I'm right now on my phone. Can you please? Yeah. Okay, I'm going to share it like right now.
Akku team, is there anything fine with your internet connection and presentation? Please be faster. Akku team.
Yeah, it's not just me, it's other persons. Um, like, sorry for that. Mm. It's okay now? Do you see it?
Yeah, we can see your screen. So we can start?
Oh, please, can we wait for another, guys? It's just only me. I don't know what's happening with them right now. Sorry.
I
What
guess
you're
some of
about
your
your
team
teammates?
members here, like there are two accounts with account names.
It's like one of them is my notebook and one of them is like my phone because I don't have
But
microphone.
But there is also another Aku member here. So there are three
And
accounts in general. So one of them should be your teammate.
yes.
So is he here or she?
Oh, let me ask him.
How much time you need to prepare?
Yeah, we need like 1 minute. He, sorry. Anyway, accept him. So like we have only 2 members, like me and another one.
Okay, so we can start with them, right? Because 2 minutes passed when you said 1 minute. I think we can start with you two. Is it fine?
Okay, yeah, I think it's fine.
Okay, you have 6 minutes to present and 6 minutes for the Q&A, depends on judges. Good luck.
Hello, dear judges. Welcome to the Aku Racing team. My name is Nariman, and I'm the team lead of Aku. These are my teammates. So our main goal is to represent Kazakhstan on the world stage. Is like to prove that Kazakhstan have good engineers. We have a good powerhouse of future innovators. So to start off, I'm going to show you our applications that we use, especially in CAD. They are Onshape, Fusion, and Ray Tracer from Autodesk. So this is our first season in the STEM racing, so we didn't even know what to do and how to build the car. So to start off, we made the ideation development, and we started with how drag race cars, Formula E Gen 1 front wing, F22 Raptor wings, and boxfish aero principle. So when we just knew that STEM racing is going to be in Kazakhstan, we made the first iteration of our car. So for our first car, we utilized an open source car platform without reviewing the new regulations, which result in a omission of the Halo and Tether 1 guides. So the first version of our front wings and rear wings were the also old version. And with our old front wing, we designed it to generate as little downforce as possible because it was thought that the car would be much more faster. But just then we realized that if it had that it could have lost control, and we only realized that once we found out the car was illegal. So for our wheelbase, we use standard parts from the official STEM racing kit, which would have been very simple but also slow because of plastic parts rubbing against each other.
Car V2 body. As soon as we realized we weren't getting anywhere, we decided to watch a tutorial on how to build a car and decided to copy it from there. And if we move into another one, Car V2 wings. The rear wing was made without an angle, just so it would be there. From this model alone, we figured out how to design our front wing so that air wouldn't blow directly onto the wheels and create drag. Car V2 wheels. Since we didn't change a thing on this car, and the designer didn't give it a proper wheelbase, we left it as is. But at least we figured out how the tetraline guides work. Engineering process. First one, analyze. We identified critical flaws in the triangle body. Major body redesigned initially to move on from sharp edges to organic low drag shells, fixed hollow tether guide compliance gaps. Second one is CAD, 3D modeling in Fusion 360 and OneShape. Third, simulate. We visualized high pressure zones on the nosecond and the wake turbulence behind the rear wing. And
so,
4. Iterate. Weight management for performance. Fine-tuned material thickness and lattice infill to reach exactly 50 grams.
So, let's start off with our final car. Its name is car, and we incorporate many design principles from the boxfish, obtained Raptor and drag race cars into our new race car and its bodywork. As you can see in the side pods, we used all the boxfish principle. It's so simple. Boxfish is so simple that when it goes into its speed, airflow doesn't go into triangle, and it follows only the straight lines because of its box shape. Also, our things that we made not looking to the other cars is our lamp and case meanings. So lamp is laminar airflow motion boundary. The lamp system is like in the simple words is diffuser, and as you can see here, if you see my cursor, when the dirty air comes into the sides of our middle section of the car, in the middle bottom section of our car, it gets sucked by the straight lines, and as it goes, it becomes smaller and smaller, and in the end, it starts to increase, so the car would get some air speed, turbo. And second one is called the airflow shaping element. So the case geometry is a cornerstone of our chassis profile, utilizing the Alcalanda effect, the side pod surfaces.
Aku team, sorry for interrupting, but your time for presentation is up. You have 6 minutes for the Q&A session.
Okay. I have question. Why you inspire from boxfish? Because boxfish is not the fastest fish in the ocean. Why you inspire from boxfish? What's the inspiration?
So really, our teacher really said that our mentor said that why not you use box shaped body, but also when after that we realized that we can add boxfish to impress you, and that also boxes have like they're not perfectly straight. They have some kind of curve going inside themselves, which make the airflow more stable.
Okay.
Also, I can show you our dogs, our analyze that the rectangle is better than the triangle.
Show, I think show.
Yeah. Yeah. It says that my internet connection is bad. Just a sec. Right here, we made the analysis using the open form and seam scale. Like right here, our one of the members who couldn't participate, write it here. Wrote it right here.
For this whole data, you use CFD analysis. You make two different model. One use in the more
No,
triangular
no.
and more rectangle. Am I
Like
right?
we made like another versions of like which are close to the bullet themselves, but not the bullet exactly. I can...
Sultan, Ali, do you have questions?
Yeah, can you open the final version of your CAD model?
Yeah. We need to like wait for the fusion to open, or wait a second. I can open it on the Onshape.
Better in the fusion. Better in the fusion.
Okay. I'm sorry. Yeah. Show track. You see it?
Yeah, we
Yeah, we
see.
can see.
Like here is the lamp.
Your time for Q&A is up. So we're moving forward to the next team. I think judges are fine.
Yeah, all good.
Okay, great. So we are moving to the next team. And
Thanks.
thank you so much. Orkin team, are you here?
Yeah, we are here.
Okay, just give me a second. Do you have the right to share your screen? Great.
Сейчас, подожди. So we can start?
Okay, we can see your screen and your time for presentation goes now.
Okay, good afternoon, judges. Today we would like to present the innovation, collaboration, and learning experience behind the development of our final car, the G9 Prime. Our innovation process was not a straight line. It was not simply about making one car slightly better again and again. Instead, we tested different aerodynamics ideas, made mistakes, and eventually learned what actually worked under real competition constraints. At the beginning, we believed that a more complex design would automatically mean a better design. Some of our earlier concepts focused on aggressive geometry, internal airflow changes, and complicated body shapes. This idea was to control airflow by guiding it through and around the car. For example, in G8.5 model, airflow was divided into multiple paths. Part moved underneath the car, while another part passes between the front wheels and the main body. The rear wheels were also partially integrated into the body to reduce turbulence. On paper, this looked advanced, but in reality, it made the car heavier, harder to manufacture, and more difficult to keep within the regulations. And this is where our engineering mindset changed. This prototype represents the stage where we're trying to make the design too complicated. It helps us learn, but it no longer represents our final engineering direction.
So we decided to leave this approach behind. After the first national round, our car was reaching around 2 seconds on the 20 meters of track. At the moment, we made a clear promise to ourselves. We had to cut at least a half second and reach 1.5 seconds range. However, the final result went beyond that target. Through the design, regulation, checking, wheel analysis, manufacturing considerations, and a complete change in aerodynamic philosophy, G9 Prime achieved a predicted race time of 1.12 seconds. For us, this proves that abandoning the old concept was measurable engineering progress. This is G9 Prime, our final concept. It represents a cleaner, simpler, and a more regulated-oriented design philosophy. Instead of trying making a car eat airflow and pass it through the body, we move toward and bullet-inspired aerodynamic approach. G9 Prime is designed to cut through the air and divide it smoothly around the body with minimal disturbance. This makes the car smaller, lighter, manufacturable, and easier to keep within regulation limits. Another important of our innovation progress was wheel development. We did not choose the wheel design based on appearance. Instead, we used FEA analysis in Autodesk Fusion 3060 to compare whole design and the four-spoke design concept. We analyzed the moment of inertia, peak stress, displacement, and the minimum safety factor. This helped us to balance mass reduction with structural strength. Manufacturing also became a major part of our engineering learning. Through our school, we had access to 3D printing, which allowed us to prototype elements using PLA tests in physical versions of our concepts, including G8.5, however, further stages. The car body must be manufactured from mandatory foam material using CNC machining. Because of this, we had considered machining tolerance, material limitations, and the risk of thin elements. And that's all.
This changed how we looked at design. A car is not successful just because it performs well in simulation. It also has to be legal, strong, manufacturable, and realistic. Collaboration also played an important role. We communicated with the Saudi team, Vane Racing, STEM Racing team, and exchanged ideas about aerodynamics, manufacturing, elimination, and regulation interpretation. This helps us see our car from another perspective and understand how other teams approach similar challenges. One of the biggest lessons we have learned was that simpler often performs better. At first, we tried to add more surfaces, more channels, and more aerodynamic features that we've seen in G8.5 that already was thrown in the trash can. But the more we tested and checked regulations, the more we understood that complexity can create unnecessary mass, manufacturing problems, and compliance risks. And that is why our G9 Prime became a combination of the best ideas from our previous concepts, but without unnecessary complexity. We kept the effective front wing concept, improved the nose geometry, redesigned the wheel support system, reduced the overall body, and removed real elements that no longer supported the new aerodynamic philosophy. And that can be seen in our results. For us, innovation is not about avoiding mistakes, it is about using them. The old prototype was not a failure because it taught us what direction not to follow. G9 Prime is a result of that learning. A car shaped by aerodynamic ambition, regulation checking, manufacturing reality, structural analysis, and collaboration. This is what defines us and our engineering projects. They are bold ideas, honest testing, and ability to throw away what no longer works and reach these numbers. So, if there are any questions, we're ready to answer them.
Great. Great. Now you have 6 minutes for your Q&A session. Good luck.
Can you open your 3D model in CAD?
Okay, give me a second. So this is our site, and you here can see our final model, G9 Prime. So
No,
also I can show
the
model in
CAD program.
Fusion.
Yeah, in Fusion. In Fusion.
Fusion, yes, please. So here you can see a final model in Fusion. So,
can you show downside of car?
Downside, yeah. This is the downside.
Ali Big Sultan, do you have questions?
Do you have a simulation of manufacturing processes?
So can you repeat the question? Yeah, you're not here well.
You make a simulation of manufacturing in Fusion or another CAD program have simulation of manufacturing. If you use CNC modeling, you can simulate how it's the produce of your model. You make like
I
this
wouldn't say
simulation.
that we have simulations, but we have an experience in PLM material printing, and that is an experience that we have used. I think it could be a good analog and even better than just simulation in After Effects because it is a real car in comparison to just simulation.
What's the material you use for your final model?
Unfortunately, as you can see, there's a PLE model on the whole car, but this shouldn't be as, like in final car, we will use this PLE material only for our rear wing and elements such as front wing, I don't know, wheels, and etc. The car material must, accordingly to the STEM Racing Singapore 2026 regulations, must be polyethylene foam. And this CNC machine and machining whole, process is described in our portfolio. That it will be through a connection with
how you produce with CNC. You found a company or
Yes. I just in our city there is a university YIKTU, East Kazakhstan Technical University, and they have there several laboratories, and one of them is mechatronics one, where they have the CNC machining, and our school NIS are in close contact with them. So our school principal told us that they are ready to help us with manufacturing.
Okay. Any other questions, Bek Sultan, Alibek?
Yeah, we're ready.
It's everything clear.
About simulation, what kind of simulations do you have?
We have simulations, if you mean like FNL, which is computational fluid. I don't know, like the full meaning of that, but the CFD was used through the ANSYS discovery, not ANSYS fluid, because it takes too much iterations and it is like typically too long, which, like their one testing is might take one whole day, and that's why we use ANSYS discovery, and we have the testings of
Wheels?
all of our cars. Yeah, all of our cars. We also have the FEA analysis of our wheels, which was already previously shown. So ANSYS
Show me
discovery,
please,
and after this to FEA analysis.
show me ANSYS analysis.
ANSYS analysis, yes, wait a minute. So for example, in our site, you can see ANSYS discovery. So for example, this is our six models, and this says six results. And then this ANSYS results about aerodynamics. And here we can see,
Show
for
me
example,
full analysis.
through ANSYS.
No, if you want, you can show through ANSYS. If you don't have ANSYS, you can make the
Yeah,
screenshot
we
or
have
put
ANSYS.
at
Just wait a
ANSYS.
minute. Just wait a minute. Просто crash after this.
Sorry, your time for the Q&A is up. So that's it.
Oh yeah, you can see like our results on our website. And also in portfolio. Yeah, portfolio too.
Okay,
Thanks.
great.
Maybe the
Thank you.
time to open this one. Is there other teams or not?
For technical part is done. So technical judge, you can leave.
Okay,
And
please ask them, send the ANSYS screenshot that they will open now in the chat maybe.
okay.
Так, у нас есть пока пару минут.
Всем привет, меня слышно? Проверим связь.
Да, отлично. Как вы?
Все. Да, замечательно. По поводу спрашивали там Skyrace, скажу сразу, они не лидеры по прошлому дню, но очень-очень-очень близко. То, что мои оценки повлияют на победу. Они буквально там, в паре тройки очков от тех, кто были самыми топами. То есть если у них
Просто
действительно
мое
очень
мнение,
высокий...
я не знаю, если сойдется с Алибеком Бексултаном, пока ни одной команды за эти 2 дня, прошлый день и этот день, нету, которые близки к производству своей машинки, уже начать делать, кроме Skyres. Ни сегодня, ни в тот раз.
Да, я буду, если кто-то будет супер крут по рейтинга, я просто буду довольствоваться неким специальным призом, специальным этим, что вот, вот эти вот выиграли приз за, ну не приз там имеется в виду, а 15 заберут там за этот. Сегодня есть одна команда, от которой у меня прямо такие супер ожидания, я прям вот жду, это Integrum. Вы вообще читали, что вы там написали? Потому что если вы читали, и тем более это, я просто буду тут это пищать от счастья. Жду очень сильно еще одну команду и жду еще одну команду, которая на полуфиналах была очень сильна, но вот что-то как-то круче, чем документы, которые они прислали, поэтому вот хочется посмотреть, как бы
Алибек, Бексултан, у вас
сохранить ли
что-нибудь есть по этим дням? Какие-то идеи?
Разочарование.
Алибек, плохо слышно было.
Разочарование, говорю.
Ну да, есть такое. Те, на кого мы сильно ставили, по итогу что-то вообще слабые. АКУ вообще не собранные по итогу оказались, хотя они из простой школы, как я понял, не из там какой-то специализированной школы. На них у меня были большие ставки на них, что-то они сегодня не организованные. Другие команды тоже какие-то слабые сегодня оказались.
Да, вообще я не понимал, что они... Ну, как бы у некоторых презентация старая, все старое.
Да, хотя должны были, по идее, как бы побольше
Доработать.
подготовить. Да. Ну, как Интегрум выступил, если что, по инженерке?
Интегрум это какой?
Это вот были, я как раз зашел буквально, вот они
А вот
были.
последние, которые... А, нет,
Нет,
предпоследние.
предпоследние, перед АКУ они были.
Блин, тоже слабенькие были, если честно.
Не надо меня разочаровывать, у них такая
Слабенькие.
классная приза.
Сегодня кто неплохо выступил, это, наверное, Огма.
Огма, да, живо. И как бы более-менее нормальная презентажка, и все более-менее... То есть из всех сегодня Огма топ. Да.
А
Они просто
Gigatronics,
знают,
которые...
о чем
Gigatronics вообще
они...
все. Вообще, если говорить про инженерку, выпадают, вылетают просто.
Они поплыли
Ну, просто...
очень сильно.
Да, и этот, просто дали документ вчера, да, вот это по маркетингу. Вот РСР ждал в прошлый раз, и вот Gigatronics сейчас. Gigatronics настолько слабый документ прислали, что я прям разочаровался. Я очень сильно надеялся, что как бы они сегодня выступят круче, чем... Ну, то есть я помню по полуфиналу они очень крутые. Но вот у меня
Вообще,
такая же история... Алло.
вообще классные, говорю, были. Я
Они
говорил, что
просто
они
не
были
доделали,
классные,
то есть
когда выступали.
они
Да.
оставили все на том же уровне.
Да.
Одна команда...
Ну что, давайте
Одна
залетаем.
команда присоединилась.
Да, давайте потом с этими обсудим вот сегодня вечером или завтра, когда вам будет удобно, чтобы мы вот все презентации прослушали и решили.
Да, у меня тут у меня все команды записаны по пунктам, так что я готов буду. И каждый в том числе по итогам дать обратную связь готов, так что. Вот как только закончим с объявлением, да, как только закончим с объявлением победителя, сразу команды могут приходить, по крайней мере, по Enterprise за обратной связью, детальной, там, все обсудим, все рассмотрим, но только после того, как победителя объявят. Все. Вот,
Все,
у меня,
всем
у
спасибо.
меня
Если
все.
что, мне нужно отключаться. Я уже
Да,
не смогу
да.
пройти на
Да, до
Enterprise.
свидания.
А Ружан, напишешь потом, когда нужно будет подключиться, я подключусь, свое мнение выскажу. Ага. Все, всем
Окей,
пока, всем
запись,
спасибо.
кстати же.
Да,
Я тогда
техническим судьям.
запускаю команду. Запускаю команду
Запись же
Organizer.
будет?
Да.
Подожди.
Запись, да, скинем.
Запись же.
Да,
все
вот
окей.
идет.
Но на записи, кажется, там Gigatronics нету. Запись поздно началась, если не ошибаюсь.
Да.
So can you start Enterprise?
Yes, it's an enterprise presentation. So can you
Yeah.
share your screen?
Mm-hmm.
So, good evening, dear judges. We are the team of Enterprise Organizer Team, and today we would like to present you the journey that shaped us as a team during the weeks leading up to the superfinals. So, our enterprise team is made up of 2 students with different responsibilities and strengths. Both of us contribute in unique ways, from design to inspiration to management and marketing. While our roles may differ, our goal has always remained the same: turning the ideas into reality while continuously improving ourselves and our team as an enterprise group. We learned that success is team racing is not only about building a fast car, it's about building a strong and united team that works in sync.
So one of our main priorities throughout this season was engagement. We wanted to introduce STEM racing to more students and create interest within our community. Through Kahoots, events, and interactions with students, we aim to show that engineering and innovations can be exciting and accessible. In this week, our team organized and participated in several initiatives. We hosted movie night and NIS at NIS and represented our club during school events where we showcase our team and values, achievements, and passion for STEM racing. These engagements not only strengthen our connection with the school community, but also helped us raise awareness about our club and inspire students to become interested in STEM opportunities. We wanted people to see STEM not only as science and formulas, but also as a creativity and teamwork and opportunities. However, our journey was not without challenges. When we entered the superfinal stage, we faced a difficult situation. Due to the unexpected situation involving casting, on the morning of May 5th, 2026, an explosion occurred in dust collection system at the casting smelter in Uсть-Каменогорск during cleanup operations. The incident resulted in a partial collapses of the structure and a fire. We suddenly found ourselves with limited sponsorship opportunities. For a moment, this created uncertainty for our team.
Instead of giving up, we decided to take initiative and present our situation to our school administration. This became an important turning point for us. Through the support of our school and community, we were connected with the new partners and sponsors, especially with the World Robot Olympiad and the Hoyer Bigger, allowing us to continue moving forward. Thanks to Hoyer Bigger, we found not only new partners, but also the support for our engineering team through making the Zoom meeting in case of creating the car details. So throughout the superfinals journey, we had to adapt and find solutions to unexpected problems. From this experience, we understood that the most reliable foundations is often the one rooted in the community right beside us. This experience taught us that challenges are not roadblocks. Sometimes they become opportunities to discover support where you least expected.
Innovation also became a major part of our journey. We organized one of the first STEM racing-related prize activities in East Kazakhstan. In our painting contest, we have given our own shirt to the winners as for the best picture prize. Moreover, we created stronger connections within our local government through connection with our Akim. We wanted to get sponsors in all ways and to make STEM racing more visible and inspire students to participate and become interested in engineering and technology. Also, our pit display reflects this journey as well. We designed it inspired by professional racing teams because we wanted to create an atmosphere that represents growth and progress. We included our earlier designs together with our final car to visually show and our development process. We believe improvement should be visible because every prototype, every mistake, and every redesign became part of our story.
So, finally, our biggest lesson from the journey is simple. Not every solution is found ahead of you. Sometimes it stands beside you. This season taught us resilience, teamwork, and the importance of community. We did not simply build a car. We built connections, experiences, and lessons that will stay with us long after the competition. Thank you, dear judges, for your attention. And for now, we are ready to answer the questions.
Great. Now you have 6 minutes for the Q&A. Good luck.
Thank you very much.
So, Dear participants, so you are looking for sponsors, so you have to offer to them some kind of ROI, a return of investment. Please, can you explain by your own words link between the engagement, you told us a lot of words about it, and the ROI, which you can provide to potential sponsors? By your own words.
No, ROI, it is a quite important part and necessary in terms of sponsorship. And that's how we actually hook this casting, which are, you know, like sponsoring a lot of sponsor events, and they know what engagement actually means. They realize, for example, they have their own marathon in our city, and our engagement, for example, in school that we have made, such as this painting contest in some related fields. And I don't know, even that movie night, it's got a not, I wouldn't say, you know, it around itself a lot of people, quite a lot of people. And by that, I want to say that engagement and ROI, it is typically one thing, because by engaging people, you show, for example, in our case, casting, that it is interesting in your community and they will get some views and just typically gain popularity.
That will lead to the popularity of the company that's sponsoring us, and with that they will like gain more for themselves.
Okay, but Qazaqstan is a big B2B company. They don't have any, you know, normal customers. They have big companies as potential customers. So popularity which you can provide to them can help them to build good relations with potential customers.
So, you know, the thing you say is actually true, but in our case and in case of our city, for example, in our city, Qazaqstan holds its own hackathon. And that way, it provides a strong social impact. And I think that our team is also their social impact. You know, like they provide and enhance the engineering level in our city. For example, we have a straight connection with them, and our team might not be the best, the best out of the best financial investment for them, but it will be a great way to improve engineering in our cities. And then for example, in our team, from our engineers, height over higher, like to the job, our engineers, for example, in future, in several years, and other
Thank you so
engineers
much,
that
guys.
will get hooked by us in our regional events.
Yeah, thank you so much, guys. Arjan, please, your question, if you have.
Yeah, I'm curious about sustainability in your project, how the sustainability is reflected in your project, because I think in your context is really important because you're in Skimnogorsk and you have some ecological issues in your city.
You say disability, yeah?
Sustainability. I'm sorry.
Sustainability. Yes, sustainability is, like it is another story. We have our partners, Ecomican, which is also an NIS movement that unites the whole 22 NIS schools. And we partnered with Ecomican, who support things as like Qazaqstan, and sustainability in our city. I think it is a problem that we can show that even in our level, in the level of teenagers, we can impact the society in the right way. And the action we did for that, and again, which is promoting Ecomican, that typically does a lot of work for us. And moreover, I think it's actually relates to manufacturing too, because when we looked and talked, for example, with Wing Racing team from Saudi Arabia, they told us that sustainability is also about manufacturing, that you recycle materials and etc. For example, this G8.5 model is already registered for, I don't know, our engineers I think know that, for a local recycling center. I don't know, maybe it's a factory even. So that's the G8.5 model that was thrown in a trash can will get recycled.
Okay, thank you very much for your presentation.
Yeah, I'm okay.
Thank you.
Thank you for your attention.
Yeah, I'm okay also.
Okay, great. So now I think we move to another team. Thank you so much. Gigatronics is now joining. Gigatronics, are you here?
Oh, yes, we're here. Let me just turn on our camera. Just
Okay.
can you see us?
Yeah, we can see you.
Can you also give permission to share the screen for one more?
Gigatronics too.
Yeah.
Они видят?
Well, can you see the presentation on the slides?
Yes, we can.
So then,
So we have 6 minutes to present and 6 minutes for the Q&A. Good luck.
An hour ago, we opened with the number 6. 6 people who built the car. Here's the number for this room. 3. It took 6 of us to build it, and it took only 3 companies to believe we would actually get it there. And not one of them gave us a handshake or a maybe. Every one of them signed a real contract. So let me introduce the 3 names that decided to bet on a team from Kazakhstan. Every team here has worked hard to build our car, and I'm proud of ours. But before I get to the car, I want you to show something that took just as much work. 3 companies have already signed on to back us. These deals are secured in real contracts signed by both sides, and you can find every one of them in our enterprise portfolio. And not one of those partners was chosen at random. Our biggest, Oman, is an architectural company. People who spend their whole careers thinking about structure, balance, and how things hold together. And they're the ones paying for the 6-plane ticket that takes us from Almaty to Singapore and back. Aprium builds software for a living, and they cover our entire week in the city. Sturgeon Capital works in finance, and they fund our registration and research. We didn't simply ask whoever we could for money. We went looking for partners who exactly think the way an engineering team has to think. And those are the people who sign on to back us. But here's the part that makes it important. Every one of those contracts depends on a single condition, that we advance for this national round. The only thing standing between us and that plane is this room, so we are not hoping to reach Singapore. We are ready for it. We just have to earn it today.
F1 in Schools is the world's largest F1 program. 1.83 million students in 85 countries. A global stage Kazakhstan has never stood on until Gigatronics, and we're built for it. Kazakhstan is one of the most sponsor-friendly markets in Central Asia. 19.5 million people online and 86% of them on TikTok, and over 40% of the whole country under 25. Exactly the audience our sponsors want. But we didn't just build a car, we built a community around it. So on 25th of May, we ran an open workshop. Students and parents rotating through 4 stations. CAD, manufacturing, aerodynamics, and branding, hands-on in our robotics lab. And our second program, build your first STEM car. Let's grade 7 to 9, pick a role, build a car, and race it themselves.
So turning that audience into something real was my job. We studied what our region loves to watch, worked out why those videos take off, and made our own. The result is right behind me. For an account with just 1,500 followers, we got 2 videos reaching over 28,000 views and 33,000. That's almost 20 times beyond the people who follow us, and it wasn't luck. One of our teammates actually runs a page with over 50,000 followers, so we knew this game right before we started. We built a fast car, then made sure the world would stop and watch it race. In Singapore this October, we intend to do both better than anyone expects from Kazakhstan.
Now, where every dollar goes and who covers it? Our total need is $5,900 and every single line of it has a name sponsor behind it. Nothing is left hanging. Ulmat covers our biggest cost of $2,500 for return flights for all 6 of us from Almaty to Singapore. Aprium covers our accommodation in Singapore, $1,750, and Sturgeon Capital covers the rest. Registration in a smaller race day costs $400. On the top of that, our school contributes 3D printing and CNC machining at no cost to us. So the bottom line is simple. $5,900 needed, $4,700 raised. We're not hoping to fund this trip. It's already funded. The chart on the right shows exactly how it breaks down.
Everything we've shown you is live right now at gigatronics.live, and we've built it to show you our thinking, not just look good. If you want to see why our tail is dimpled instead of being smooth, the airflow, the wake, the track numbers are all there. If you want to see how an idea becomes a part, the full pipeline is laid out: design, simulation, machining, and testing. We even put our budget on this page line by line, and nothing is hidden. And at the center of it is the car itself, which you don't just look at, but actually control. But that's the part I'll let Diaz talk you through.
As mentioned previously, our website is live and open to everyone. On it, you can run a full airflow simulation that shows exactly how air moves over every surface of our car, with labels, explanations, and a fully interactive view. Sponsors, judges, and anyone in the community can examine our aerodynamics and CAD work at their own pace from any angle without any special software required. And that accessibility directly helped us win sponsors. They didn't have to take our word for it. They could see the engineering themselves, interact with it, and understand exactly what they'd be backing. Further down, you'll find the CAD renders and a full 3D rotational reveal of the finished car. With that, I'll hand over to Kirill.
Thank you, Diaz. Now, if you'll keep scrolling, you'll reach something that might surprise you on the engineering team's website: a shop. Team shirts, caps, bracelets, it's own in our own livery. And the reason it's there is simple. Every single thing you buy goes straight back into getting us to Singapore. Individual support comes from anyone who believes in us, even a little.
Gigatronics, your internet is lagging.
Я уж
Gigatronics.
испугался, что это у меня.
Gigatronics. Gigatronics. Они вылетели.
Я им написала.
Да, и зря я уж даже вопрос придумал. Интересный. Пока смотрел. Да, это обидно будет, если они не вернутся. Я его хочу задать. Ладно, ждем. Я не отключаюсь здесь пока. Посижу на мьюте.
Они просят 2 минуты.
У меня не работает дома.
Okay, they're here. Hello,
yeah.
Gigatronics. So your time for presentation is basically up, like when you was
Yeah.
there and talking. So I think you can just use this screen and we can do the Q&A
Okay.
session.
Yes, okay.
Is it fine
Just,
for Judge?
can
Yeah,
I
yeah.
also ask one question, please?
Okay. What
Did
question?
you hear the bit with our confirmation of order and stuff that we're
Okay.
Yeah, we heard it.
Okay,
so
great.
that's fine. The last slide, because it shows our confirmation of order, that actually was a real thing.
Yeah, that was our end of the presentation, by the way. So yeah.
Okay, great. So you have 6 minutes for the Q&A. Good luck.
Yep. Let's go back to the audience research. I saw one slide, a few slides before.
Well, let me just, because our second device cannot be connected, let me just maybe,
Yeah, you can show it on your screen. I see it.
okay, let me just,
You can show
I'll
it
sign
from the
in.
television behind you, so that's fine.
From the television,
Judge
but the
said
problem,
they can see it.
let us just, slideshow, and let me just screen share it from mine so that it'll be convenient, yeah.
Because the school Wi-Fi has went out, that's why we're just reconnecting from this device only.
Yeah. Can we see my screen right now?
Yes.
Okay, let me just do the slideshow. Yep. And now let's just move on to the enterprise part. Yep. There's the okay, yeah.
Let's go to audience.
Audience, yeah. Audience, it's this tab. Yep.
What was
Can you see it?
No, just first slide with your teammates.
Like the really first one or the
No, I see right now. I see only the first slide with your teammates.
Okay, let me just...
Yeah, but
okay,
I need the.
Okay, let me just share the whole screen.
Okay.
Yeah. Yep. Can we see it right now?
Yeah. Let's go to audience. Audience.
Yep.
Oh yeah. Search analysis implementation. Do you have any results of any audience analysis or audience research?
So we have personally researched and we heavily based, since I've mentioned that our team has over 50,000 followers on our social media, and we wanted to target that specific audience of young, because mainly his audience is age from age of 10 to 25, which is the perfect thing for us.
One question. Do you know how much of your audience, which percent, is 35 years old?
35, approximately
35.
35%, about not that much, about 10 to 15, about 30%. I guess let me just check again.
Less than 35.
Okay, let me just...
Less than 35, it was approximately...
No, just approximately.
35? Oh, less than 35, then it's, yeah, that's a majority.
It's probably like 60% of the whole...
I thought it's only 35, sorry.
Yeah, as we mentioned before, the audience under the 25 years old takes up to 42.4% of all internet users in Kazakhstan.
So you did any research, or you just trying to...
Yeah. So we did research.
We had some research using the
Data Reportal Digital website.
For Kazakhstan.
We had data reports. Our research analysts use data reports, like as seen here.
Okay. Just second question. How you research your audience? How you calculate it?
Okay, so we first let me just, so I'm as a marketing agent, the first thing that I look at is the first post that we posted, since we thought that the most active and the most precise audience that we could target is those who age below 35. Account, and that's the video I've specifically designed to suit the age group below 35, which is just a simple trend with a story.
Okay,
and from those analysts...
second question. Male female audience. Which percent is for male audience? More than 50%, less than 50%?
There isn't concise information, but the approximately would be 50% for both, even though we don't really have the full information.
Because the majority of Instagram are...
they don't take into account the gender.
Yeah.
Okay, thank you so much. So Arjan, your time.
Tell me, how did you convince these companies to become your sponsors? Like, what was the procedure?
Okay. So the first is we have successfully convinced 3 companies, as we have mentioned previously through our website. It's just the matter of wondering our website and our pitching, because the thing that we did is that we cold email and we outreach those companies in person, which as marketing leader, I believe in personal connection. So it's not just emails. And then the first thing that we did is outreach them in person. And then our website was just one of the most helpful things that helped us to explain to our sponsors the thing that needs funding, and especially our 3D design and ability to rotate it has especially helped us and reduce the strain of explaining everything into one simple graphic that helped us to secure our sponsorships. And that was the matter of our website and our communication that helped us to secure those sponsorships.
You can find all of the signed contracts regarding the sponsorship deals on the internship portfolio.
Yeah, there is a huge button with the link on them, and there is a Google Drive folder.
Have you already submitted your portfolio?
Yes.
The portfolio was submitted as a draft yesterday. I sent you on Telegram. As you must know that we have an extension to the 27th. We're gonna upload it on the 27th, the fully finalized version of both
Your
technical
time
and
for Q&A is up. I'm sorry.
1 minute. Can you send your portfolio tomorrow, not in the midnight, before 2 p.m. or even earlier is possible?
Okay, we
Because
will as early as possible.
and also last question, how is the sustainability is reflected in your project?
I'm sorry, could you repeat?
How sustainability is reflected in your project?
So the sustainability drives from our architecture and the fact that of our teams choosing the right companies, because we specifically we have read the terms applied for the internship portfolio and the internship outreach.
We
and the terms.
use community outreach to inspire younger people, and also the Sturgeon Capital, a financial investment, only uses ESG investments, so our sponsors are all sustainable.
Yeah, they're sustainable. We also recently ran a completed workshop with the younger audience, and we haven't used we attended what our robotics labs in our school offer. They do not offer non-sustainable materials. There was only things like wood, and the CNC machine that we were talking about was there, and we showed the students everything about the CNC machine, and all of the materials that the school provides us is actually mainly everything sustainable. So the way that we taught the younger generations is based off the sustainable base. So that's
about it.
Yeah.
Okay, thank
Are
you
there
very
any-
much for your presentation.
Okay,
Thank
you
you.
very much.
Goodbye.
Thank you. Just.
У нас кто следующий?
Огма, но их пока
Оружа-
нет.
Да,
Нет.
команда Огма. Сейчас я напишу.
Никого нет?
Никого нет, но запись идет.
Ну окей. Не, ну это я просто... Вот. Так. Ну что ж, ждем следующего участника. Посмотрим. Тянутся 9. На сей раз. Так, ладно, когда вернется, я тоже включу микрофон.
Хорошо, без проблем. Команда Огма присоединяется. Hello, Ogma team. Do you hear us?
Hello, yes.
Okay, can you share your screen?
1 second. Can you see our screen?
Yes, we can. Yes, we can.
So we can start?
Okay, you can start. You have 6 minutes for the
Yes, yes, yes.
presentation and 6 minutes for the Q&A. Good luck.
So, hello, we're Team Ogma from Almaty, Kazakhstan. We position ourselves as a youth engineering brand that connects our development, entrepreneurship, sponsorship, STEM education, and Kazakhstan's international representation. Our mission is to use our engineering and enterprise experience to promote STEM racing across Central Asia by educating rookies, mentoring future participants, sharing our resources, and proving that students from our region can compete internationally. To keep the team organized, we build our work around the Ogma rule: originality, growth, motivation, and ambition. These values are converted into measurable goals. Our team management is divided into engineering and enterprise departments. Each department has a head, project managers, and project executors. This team structure was inspired by the guide published by STEM Racing, supporting the team contribution. Our logo represents motivation forward and combines the letters of our team name, while the name of our team represents ancient belief about knowledge.
Then third goals are sponsorship strategy. First of all, we made a general plan which includes list of expenses. Generally, we divided it in 4 parts. It's car manufacturing, outreach initiatives, speed zone manufacturing, and logistics. But manufacturing and logistics are the highest priorities because they are the most costly. And for the first strategy in our sponsorship, we called it strategic sponsor fit because there we research for companies, then contact with them, and we only choose companies that are connected with engineering, education, technology, and motor or YAS development, and then we contact with them, and with value-driven pitch, we follow up and build a partner database. Our current sponsors like Expartus, Ed for You, and other partners we got by this strategy. But there it goes more innovative one. It's about career first partnership. Before asking for money, we request company visits like excursions, lab tours, and then we go for internships to show that we actually have skills that they can invest into. This allows the company to see us as a motivated technical talent first. For example, we visited the Hyundai factory and Aston Motors to learn from them. And for now, we have an internship agreement with them that is going to start in June. And our third strategy is strategic industry partnership for companies like Gas Minerals and other firms that have a weak charity sector. We choose them to suggest us as an opportunity to invest into educational initiatives. So our sponsorship model is invest in visible, measurable, YAS engineering and platform. And we also divided it based on our expenses as title sponsor, which invests in the most costly initiatives, technical partners that can donate some equipment, community partners that can give us a place to hold our outreach initiatives, and media content partners that can share with our Instagram.
So next, we're going to be talking about the marketing strategy. Our marketing strategy is based on a simple idea. We're not trying to compete with large STEM projects or professional media channels directly. Instead, we use the approach from the marketing warfare by Race and Trout, mainly flanking strategy and guerrilla marketing. Our flanking strategy means that we choose a narrow but a strong niche. Ogma Racing is not just about building a car. We present it as a mix of engineering, entrepreneurship, design, STEP education, and Qazaqstan representation in international competitions. This makes our project more unique and easier to remember. At the same time, we use guerrilla marketing because we do not have a large marketing budget, so we focus on low-cost but high-impact actions that are relying on our team missions and might be long-term. School outreach, company visits, sponsorship, pitches, public meetings with Alexander Artemiev, and etc. Our main goal is to turn attention into trust and from sponsors, partners, students, parents, mentors, and engineering experts. That's why our content is aimed at different audiences.
So yeah, talking about feedback from Alexander Artemiev, first of all, he noticed us on social media and wrote that, but we also decided to write him about mentorship and other feedbacks. He gave us feedback about our car and aerodynamics, but we wanted to make just broader, bigger collaboration, like bigger events, make the meaning. So we organized a meet with him, with the 22 plus participants, where he shared his experience, connected with motorsport, and gave his own advices for the students who love motorsport and engineering.
We also work on sustainability. Material we prototype in plant-based PLA. Use non-toxic paint and glue, and recycle through EcoHub.
Yeah, and the economical sustainability, our economic sustainability strategy is based on the idea from the marketing warfare. Small operators should not compete through scale, but through focus, speed, positioning, and efficient users of limited resources. For Oman, this means that every expense, partnership, event, and marketing action must create measurable value.
And then to create a real value, we start with community impact. First of all, one of our main projects is collaboration with Inclusive Academy, because as we want to make STEM more accessible in our mission, we connected with them with our games published on our website that can be neurostimulating for children with special needs. Thus, 70 volunteers included it in their practices by now. And also rookie introduction to STEM racing, which make our team sustainable as we introduce STEM racing for future generation of our team. And also we created bootcamp not to introduce STEM racing only for rookies, but also
Sorry for
to
interrupting, but your time is up for the presentation, and now you have 6 minutes to answer the Q&A.
Okay.
Good luck.
Yeah, thank you so much. So you told us that you're in negotiation with Astana Group. Is it true?
Yeah,
Astana Group.
I can show you the actual. Sorry, I interrupted you.
Yeah, Astana Group has a very wide portfolio of brands they represent, car brands and such brands like Mega, shopping malls. Which brand you project, or you want to discuss with them that between Astana Group brand and your team, and tell me why you choose specific brand or general Astana Group brand. Explain me why you make such choice.
Okay, thank you for your question. Answering it from the first, we chose exactly Hyundai factory because it's the biggest sector of Astana Motors in mechanical engineering. And as we mentioned before, our sponsorship strategy is based on choosing the exact companies that can align with our team goals and skills. And Astana Motors was a great match for career first partnership, because here we are not only talking about asking money from them, but also agreeing for internship, because Astana Motors is a leader in mechanical engineering, and as we are representing our team as mechanical engineers, we asked them to. We actually got an agreement on last week, where we came to their main office in Mega and negotiated with their main CEO in Almaty. And they are waiting for the list of engineers from our team and our school to enter internship in June. And then we are planning to negotiate more investments
Thank you so
in more
much.
than.
Sorry, sorry for interrupting. Thank you so much. Time, please.
Okay. So let's imagine that you've been chosen as the winner of this season. What are your plans for the summer?
Okay, so if we were winners of the season, then of course we need to understand that we go back to our expenses, and most of them are logistic expenses. For them, we need to reach out for title sponsors of our team, because expenses reach $13. And we already got some companies we can negotiate with for that. Like, even if we got minor investments from Ed4U or Expanders, we are looking for major investments from Astana Motors, and also negotiation with such group as Gas Minerals.
In addition, we also have an negotiation with F1 Kazakhstan, which promised us if we go to Singapore, they will give us the informational and
Technological support.
Technological support, yes.
I remember your presentation from technical part. You can show your pit zone right now for Max.
Oh my god. Pit zone.
So
the
Max,
cut our
they had interesting ideas for their pit zone during the World's competition.
Great.
Sorry?
Cool.
Yes.
Yeah, thank you so much. Please, all the materials to Arjan, final materials, because I saw your presentation actually, so in both technical and enterprise. So yeah, I saw it.
But just in addition, it's made out of the recycled carbon, and it will produce the cardboard. So yes, cardboard, and it produces the electricity from the BLDC motor that I mentioned before.
So the participants can charge their phone maybe on our pit zone during the competition.
And have interactive games on the tablets.
Yeah, okay.
Thank you so much. Yep,
Thank
great.
you.
Arjan, any questions?
Yeah, maybe last question. What is the weakest part of your team and project?
For now, we identify our weaknesses such as in our team management, as much as we have team roles actually distributed within our members, we still are looking for measurable tools to make our team meet time deadlines more efficiently. And we actually communicated on that with Alikhan Sherikov from Stanford University, because he actually was the head of Inspire in First Tech Challenge last year. And he told us about Gantt chart efficiency, that we can actually put there our long-term goals and break down this for each week and tackle our weakness in meeting time deadlines.
Okay, I see. Thank you very much.
Is there any questions left? We are pleased to answer.
Yeah. If there is no, we can actually add on the parts that missed in our presentation, namely social media strategy, if you don't mind.
No, I think I'm okay with this team. So great. Arjan, any questions?
No, I don't have questions. Thank you.
Okay.
You.
Thank you so much.
Okay, it's that's it. Yeah, thank you very much for listening.
Thank you so much.
Thank you so much. Yeah.
Thank you. So next team, it's Team Integram is joining. Ogma Racing, thank you again.
Можно с Интегрумом? Я написал там, да, в чатике, что я сейчас с ними как бы, порулю немножко, потому что у меня к ним прям есть вопросы. Вот.
They're here, right?
Yep. So I will make some short. Yeah. Hello.
Let me share the screen.
Yeah, guys. One question from me. Please, can you make short presentation, 1 minute, maybe, because I already saw your document, a really short presentation, because I have one question for you, and it will be not so short, I think, in answering.
Okay, you have 2 minutes for the presentation, 2 minutes only. It will be strict with that one.
Okay.
And after that, you will have 6-8 minutes for the Q&A.
So
Okay,
we have shortened pitch length, right? Can we
Only
pitch
2
fully
minutes.
sorry, can we pitch fully because we prepared for the full pitch? We just didn't know that we would have this situation.
It depends on judges.
You can make full pitch, but I think I saw your document because I want to ask you the question, and it depends. No, okay, you can make a full pitch, and we can go.
We just want to make it clear for all of the judges. Okay, so
okay,
I'm sharing the screen right now. Is it visible?
Yes.
Yes. Okay.
Okay, you have 6 minutes to present and 6 minutes to Q&A then. Good luck.
Okay, I can start. Hello, judges. Long time no see. We are Team Integrum. I'm Arman, team captain and engineer.
My name is Camila, and I'm the engineer of the team.
My name is Anger, and I'm enterprise manager of the team.
My name is Ansar. I'm the CAD engineer of the team.
I am Oscar, and I'm designer of the team.
Okay, let's talk about our brand identity. Integrum means whole, complete. One name, 5 different schools, one shared obsession, engineering and competition. Our name represents the idea that real success and victory comes from working together, combining our skills while sharing the same values. We started with light blue and white representing Tengri, the sky, and our national identity. After our first finals, we evolved to a purple and black galactic design, symbolizing innovation, technology, and ambition. Our current branding blends respect to our roots with a vision for the future. Our uniform and pitch display are among our strongest brand recognition tools. They reflect our identity, values, and professionalism, helping us to create a memorable image and stand out both on and off the track. We also are in a partnership with the F1 LA that gives us access to their sim race simulators on our pit zone.
Okay, we have 3 main goals. First, to become the leader on every single platform among Kazakhstan and international teams. Also, to leave our own digital footprint and attract any sponsors while preparing for the Singapore. And last but not least, to create a really strong STEM racing community since it's the first year of this competition in Kazakhstan. And how are we achieving this goal? First of all, workshops and lectures in schools like NIS, 93rd School, American Space. Also, we're visiting universities like Kazakh British Technical University or maybe SDU or Nazarbayev University. If we're talking about our connects, we have 10 strong connects with international winners and national winners from other countries like UK, India, and others. And also Kazakhstan teams. For example, Hantengri, we were talking to them about testing our car on their map or mentoring the Q Racing team. But how do we achieve the sponsorship goal? My teammate Alem will tell you about it.
Right now, we have 5 active sponsorships. Our sponsorship strategy was designed to create a clear value for both our team and our partners. We combined LinkedIn outreach, cold emailing, and personal networking, sending our 100 target messages and securing 5 partnerships through tailored and research-based speeches. Our B2B approach focused on engineering and education organizations like American Corner and NIS. We studied each company's goals and aligned our proposals with their values. In parallel, our B2C strategy grew our digital presence on Instagram, TikTok, Threads, and YouTube through social educational content. Our sponsorship model is based on return on investment. Partners gain visibility through branding in our car and uniforms. Social media promotion, we make workshops and direct engagement with the STEM community. Key partners include Hoffman Aluminium, providing CNC manufacturing and materials, Satpayev University, offering lab access and technical support, F1 ALA, supporting media outreach, American Corner Almaty, providing the technical and offering financial educational backing. And aerospace, along with NIS Almaty Mido, they offer us financial aid. Together, these partnerships strengthen both our projects and youth engineering culture in Kazakhstan. And now, Askar will talk about digital media presence.
In 1 month, we hit 88,000 impressions across TikTok, Instagram, YouTube, LinkedIn, and Threads. As you can see from the number of on screen, we more than doubled every metric from the national final to the super final. Our goal was to dominate social media among national teams and build a foundation for sponsors. We became the leader among all Kazakhstan teams. Also, we built a full ecosystem. Our website works as a central hub for judges, sponsors, and followers. We run an educational journal to bring the next generation into STEM racing. We reached out to over 100 international teams on Instagram. We are proud to be collaborating on Instagram with you, STEM Racing Kazakhstan. We received recognition, repost of Off the Track, one of the most influential STEM racing channels internationally. We featured us on their Instagram. Economically, we printed our prototype out by using PLA. For prototype, same efficiency, however, more eco-friendly and less costed compared to ABS filament, which costs 8,000 tenge.
In social sustainability, we run CAD workshops in schools across Almaty, teaching students the same tools we use, because inspiring the next generation is part of our mission. In ecological sustainability, we launched Integrum Green sub-brand. We clean up in our hometown, volunteer at UNICEF, and also we invite other teams to join us. And this was Team Integrum. Thank you for your attention, and we're open to answering your questions. Yes?
Okay.
Okay, great. So now you have 6 minutes for your Q&A session. Good luck with that one.
Yep, let's go back to the ROI.
Yes. Is it visible?
Yep. B2B strategy and B2C strategy. Can you please divide me ROI into B2B approach and B2C approach? By your own words, how you understand it?
So, okay, so for B2B, as I said, we reach out to some kind of companies using LinkedIn and other emails. So for companies, we offer seven kinds of covering that vary with 5 different levels. For example, Zhirao is the lowest level of ROI. The lowest level of our offering, and Han is the highest level. So for Zhirao, we only offer our website covering, our newsletter, and also featuring on our portfolio. While for Han, the best level for the B2B sponsorship, we offer our logo placement on our uniform, on our site, on our bolide, and on our flag. So for in B2C, we mainly use B2C to grow our audience, and so the other companies would have the higher visibility in us. So we make short form engaging media, and also for B2C, we make other content that's related to the companies that sponsor us.
Okay, but how logos on your uniform help to your potential sponsors with a B2B ROI?
What? Sorry. One thing. What?
Yeah. How logos on your uniform helps to your potential sponsors to increase their B2B ROI?
So basically, while some sponsors offer some financials or they offer some CNC machines, we offer them the placement on the logo on our uniform. So what it does is it creates a high vision, a vision that this company supports the team, the youth, and the engineering. And also the second thing is when they get featured on our logo, when we will get to the world stage, we will get a lot of social media coverage, and a lot of people will see how exactly this company supports this team, and it makes it a good and trustable brand. And also the third thing is that the logo placement, it makes the company more popular. So both in international way and both in the Kazakhstan.
Thank you so much, Arujan. Your questions?
What is
sorry.
the weakest part of your project?
What?
What are the weakest part of your project or team?
So basically, one of the enterprise part, we think that we need to acquire more sponsorships because we only covered the 70 or 80% of the financial costs. So that's why we are planning to acquire more sponsors. Right now, our financial and general sponsors are NIS network and aerospace. So they could cover about $13,000 of all of our financial expenses. So I think personally one of the hardest and one of the weakest part of our enterprise portfolio is the sponsorship management.
Okay, I see. Thank you.
I'm okay.
And also, sorry, one thing that I wanted to cover that for B2B, for companies, we provide also internships, and we organize some kind of events and workshops to with collaboration with these companies. For example, for American Space, we made a collaboration with them featuring CAD learning, and in the future we will make more workshops and lessons like this.
Okay, thank you so much. I think I understand everything.
Do you have any questions?
No? Arjan?
No. Thank you. See you guys.
Okay,
Okay,
great.
thank you so much. This was Team Integral. Bye.
Bye.
Аку Тим пишет, что у них проблемы сильные. Наверное, они не будут участвовать, потому что это опять надолго останется.
Что они последние?
Да, у нас все.
Получается, больше не будет, да? Как я понял.
Да.
Хорошо. Тогда рекординг уже завершаю.
Ой, да, я сейчас поделюсь этими